I hope that you are ready to hear something that will shake you up, wake you up, and push you to become the person you want to be. The harder you work today, the easier your life tomorrow. Every hour of effort today compounds your future rewards. And don't try to climb the whole mountain in one day. Start by taking small daily steps. And also remember that nobody will make your dreams come true except you. And let's get into today's topic, that is on test of significance small samples. In my earlier video, I have taught you about the small samples with a single mean. And in today's video, we are going to discuss about the student t-test for difference of means. See, let x bar and y bar be the means of two independent samples of sizes n1 and n2. Here n1, which is less than 30, and n2 is also less than 30. Whenever the sample size is less than 30, we have to consider it as a small sample, and we have to go with the student t-test drawn from the two normal populations having the means mu1 and mu2. See, if you observe, there are two means here, sample means, and there are two sample sizes n1 and n2, and the next one, population means, are also two, mu1 and mu2. To test whether the two population means are equal, that is, to test whether the difference mu1 minus mu2 is significant. See, as usual, there are 5 points here. First one is the null hypothesis, mu1 equal to mu2. Alternate hypothesis, mu1 not equal to mu2. And if sigma 1 is equal to sigma 2 is equal to sigma, then an unbiased estimate S square of the common variance sigma square is given by, so this is the formula here for standard variance. So this is S square is equal to N1 S1 square plus N2 S2 square by N1 plus N2 minus 2, where S1 square and S2 square are the two sample variance. So we have to calculate the variance using this formula. And the next one here is, and after finding the standard deviation, we have to, after finding the variance, we have to go with the standard deviation ST, that is root over n1 s1 square plus n2 s2 square by n1 plus n2 minus 2. So this is most important. And the next one is the test statistics. So this is the test statistics for T. The test statistics is, the formula here is, the T value here is x bar minus y bar by s into root over 1 by n1 plus 1 by n2. So first one is null hypothesis, alternate hypothesis, test statistics. So we have to calculate x bar minus y bar by s into root over 1 by n1 plus n2. And the next one is the level of significance, whether level of significance is 1%, 5%, like that. If it is mentioned, it's okay. If it's not mentioned, we have to consider every time as 5% level of significance. And the next one is the conclusion part. So here we have to calculate the test statistics using this formula. So we calculated the value of T, and we have to compare with the tabular value at alpha level of significance. Every time this is alpha level of significance, we have to compare the calculated value with the tabular value. If the calculated value of T is greater than the tabular value, so immediately we have to reject, or else we have to accept the H naught at alpha level. Otherwise, we have to accept this one. So if the calculated value is greater than the tabular value, we have to reject. If the calculated value is less than the tabular value, we have to accept a H naught. And the next thing here is, for the difference means, 95% confidence limits. So this is the formula when two population means are given, when two sample sizes are given. So this is the formula, that is x bar minus y bar plus or minus T alpha into standard deviation into root over 1 by n1 plus 1 by n2, where alpha is 0.025, that is 5% level of significance at 99% confidence limits. So here there are two formula here for 95 and 99% confidence limits. So here the formula is as usual, that is x bar minus y bar plus T alpha into S by root over 1 by n1 plus 1 by n2, where alpha is equal to 0.005. So these are all the formulas, and these are all the process and the procedure for calculating mean, test of significance for small samples, a student t-test for difference mean. So let's get into the today's problem, that is example 1. See here the samples of two types of electric. So here again the two types of the electric bulbs were tested for the length of the life and following data were observed. So this is type 1 and this is type 2. Here if you observe, the sample size n1 is equal to 8 and n2 is equal to 7, and the sample mean x bar is equal to 1, 2, 3, 4, and y bar is equal to 1036 hours, and the standard deviation S1 is equal to 36 and S2 is equal to 40 hours. So this is the data given, that is two sample sizes, two sample means, population means, standard deviations are given. So here what is it is asked, is the difference in the means sufficient to warranty that the type 1 is superior to type 2 regarding the length of the life. So let's get into the solution. Since the sample sizes are small, so if you observe, both the sample sizes are less than 30. So we consider that the sample sizes are small and sigma 1 and sigma 2 are not known. So here they are not known here. The sample standard deviation are only known. Use t-test and let mu1 and mu2 be the two population means. The first one, we go with the null hypothesis. Every time we have to start with the null hypothesis. Here the null hypothesis is H naught. The two types 1 and 2 of the electric bulbs are identical. Here mu1 is equal to mu2. So now the alternate hypothesis, as usual, that is mu1 not equal to mu2. Since the two sample means x bar and y bar are given, so here x bar is given as 1, 2, 3, 4 and y bar is given as 1036. And also the sample standard deviations S1 and S2 are also given as 36 hours and 40 hours. And we have to use the test statistics. T is equal to x bar minus y bar by s square root over 1 by n1 plus 1 by n2. So here we have to calculate this s bar using this formula. See here, this is so important. This formula is so important that s square is equal to n1 s1 square plus n2 s2 square by n1 plus n2 minus 2. So what is n1 here? So n1 is nothing but 8. So this is 8 into s1 square. So this is 36 square plus n2 is equal to 7 into s2 square, that is 40 square, divided by n1 plus n2 minus 2, that is 8 plus 7 minus 2. The value here is 1659.08. So after getting the variance, so we have to go with the standard deviation. The standard deviation will be obviously root over 1659.08. Clear? And now we have to go with the test statistics. The formula here is this one. Test statistics is x bar minus y bar by root over s into 1 by n1 plus 1 by n2. So what is x bar here? So x bar is very clear as 1, 2, 3, 4 minus y bar is nothing but 1036 divided by root over. So this is S value is 1659.08 into 1 by n1 plus 1 by n2. That is 1 by 8 plus 1 by 7. The value here is 9.39. So here after getting the calculated value, so we have to go with the degrees of freedom. So here the formula for the degrees of freedom is also very interesting. That is n1 plus n2 minus 2, the formula. What is n1 here? 8 plus. So n1 is 8 and n2 is equal to 7. That is 8 plus 7 minus 2. The degrees of freedom here is 13. So we have to take at 5% level of significance. As I show you, this is the tabular value for T distribution. For T distribution, V degrees of freedom. So what is the degrees of freedom here? 13. So we have to go with 13. And we have to go with 0 point, that is 2.160. See here, 2.160 for 5% level of significance. Very clear at 13 at this one. 5% level of significance is 2.106. So this is the tabular value. And if you check the calculated value with the tabular value, so clearly, if the calculated value is greater than 3, you simply reject the null hypothesis. So that is the note given. And here 9.39 is obviously greater than 2.160, and therefore the calculated value of T is greater than the tabular value, and therefore we are going to reject the null hypothesis. If the calculated value is greater than the tabular value, we have to reject and we have to conclude that. So what is the conclusion part? The conclusion that the two types of bulbs, that is 1 and 2 of the electric bulbs, are not identical. So this is how we have to check, and we have to go with null hypothesis, alternate hypothesis, test statistics, level of significance, and the conclusion part. And let's start the second example here. The two means of the two random samples. So here the two means of the random samples of sizes 9 and 7. So here what is given? N1 is given as, sample size is given as 9 and sample 2 is given as 7. And also the means. So what are the means here? The means are 196.42 and 198.82. So this is x bar and this is y bar. The sum of the squares of the deviations of the means are 26.94. The sum of the squares, that is the sigma x minus x bar whole square is equal to 26.94, and sigma y minus y bar whole square is equal to this value is 18.73, and this is the sum of the squares of the deviations. See, every value is given here. So now we are going to calculate S square, variance square, that is sigma. See here, sigma x minus xi minus x bar whole square plus sigma yi minus y bar whole square by n1 plus n2 minus 2. So this value is nothing but 26.94, and this value is nothing but 18.73 by n1 plus n2 minus 2, that is 9 plus 7 minus 2. The value here is very clear as 3.26. So this is the variance value. So S square we got as 3.26, and therefore the standard deviation is equal to root over this is 2.26, which is equal to the standard deviation is equal to 1.81. Use your calculation check, that is 1.81. So after getting all these, so we have to go with the null hypothesis. So the null hypothesis is very easy. That is, two samples are drawn from the same population, that is mu1 equal to mu2 you have to take. Alternate hypothesis, mu1 not equal to mu2, and level of significance alpha is equal to 0.05, and test statistics here. For the test statistics, t is equal to x bar minus y bar divided by s by root over 1 by n1 plus 1 by n2. What is x bar here? So x bar is nothing but 196.42 minus 198.82 divided by, so this is the standard deviation, that is 1.81. So this value is 1.81 into root over 1 by n2 square or n1 square. So that is 1 by 7 plus 1 by 9. So this is the value. So you have to check with the calci, and the value here is minus 2.63. So we have to calculate the modulus, take the modulus, and therefore the calculated value here is 2.63. And after calculating, so we have to check the degrees of freedom. So the degrees of freedom value is equal to n1 plus n2 minus 2. What is n1 here? 9 plus 7. So this is 9 plus 7 minus 2. That is, if you check this one, 9 plus 7. So the value here is degrees of freedom, that is 14. So the value here is the 14. So we have to check for 5% level of significance. For 14, then 5% level of significance. So as this is the table for 14, so this is 2.145. So for degrees of freedom, the tabular value, that is T alpha is equal to 2. Just now told you at 14 we have to check with 2.145. See, at 2.145. So this is the calculated value, and this is the tabular value. So now we have to compare. So 2.6 is greater than 2.1, and therefore the calculated value, so mod t is greater than the calculated value, and therefore we have to reject H0. So H0 is rejected. And what is accepted here? H1 is accepted. So we have to accept the H0. Therefore, the conclusion that the two samples are not drawn from the same population. So here we have to conclude that. So we have to reject this one. And two samples are drawn from the same population is false. And we have to conclude that the two samples are not drawn from the same population. So this is the conclusion part. So I have taught you all the formulas here regarding the difference mean. So there will be two sample sizes, two sample populations, and standard deviations, two standard deviations. And obviously this is the formula for the variance, and if you take a square root, we will be getting a standard deviation, and we have to use this test statistic formula, that is x bar minus y bar by s square root over 1 by n1 plus 1 by n2, and for degrees of freedom, this is the formula n1 plus n2 minus 2, and please, we have to check with the tabular values, and all the tabular values will be at the back side of the textbook, and definitely it will be very helpful if you take a Xerox copy and if you compare those two, and in the examinations definitely they'll provide. Thank you so much for watching. If you really like, you know what to do, please pass it on to as many friends as you can. That is the greatest help needed. And go to the playlist, and every video is uploaded for your preparation. Please avail that one. Practice well. Thank you so much.